Hello guys, in our first topic we're going to discuss about patterns and sequence. So what is a pattern? Pattern is a consistent and recurring trait that serves as an indicator in predicting the future behavior of an object or a thing. Here we have some examples of patterns. In our first example, there is a sunflower, rose, sunflower, rose. So what is the next flower after the rose? Here we can observe that the pattern is after a sunflower there will be a rose, and after a rose there will be a sunflower. So here we can assume that the answer will be a sunflower. And the next example is a sequence of numbers. But before we answer that, what is a sequence? A sequence is simply a set of numbers in particular order, or a set of numbers which follow a pattern. A basic example of sequence is 1, 2, 3, 4, and so on, which follow a counting pattern. The three dots are referred as ellipses, which means and so on. Another example is 0, 6, 12, 18, 24, and so on. In this sequence, we can observe that the pattern is by adding 6 in each number. Going back to patterns, determine the next number in the sequence for 8, 12, 16, 20, 24. Here we can notice that the pattern is by adding 4 in each number. 4 plus 8 is equals to 12, 12 plus 4 is equals to 16, 16 plus 4 is equals to 20, 20 plus 4 is equals to 24, 24 plus 24 is 28. So the answer will be 28. But we can also solve this by a formula. A sub n is equals to a sub 1 plus n minus 1 times d. N is the term we're looking for. A sub 1 is the first term. D is the common difference. So for the common difference, you have to minus the first term from the second term. Here we get 4, since 8 minus 4 is equals to 4. After getting the common difference, you can now substitute values and solve. So the answer you'll get is 28, which means the seventh term in the sequence is 28. Our second topic is about symmetry. Symmetry means that one shape becomes exactly like another when you move it in some way. Either you turn it or flip it. And one kind of symmetry is the bilateral symmetry, which is when you put an imaginary line across a figure, it will be divided into two equal halves. And here is an example of a figure in which if you draw a line across it like this, it will be divided into two equal halves. And another kind of symmetry is the rotational symmetry. It is when you rotate a figure less than 360 degrees and still achieve the same appearance of the original position. It is called angle of rotation. An example here is this flower with 3 petals. So the order of rotation in this figure is 3. That means it is how many times you can rotate this figure before getting back to its original position. And to solve for its angle of rotation, just have to divide 360 degrees by the number of angles or the order of rotation. So 360 degrees divided by 3 is equals to 120 degrees. This means that the angle of rotation of this flower is equals to 120 degrees. The next topic will be packing problems, a class of optimization problems in mathematics that involve attempting to pack objects together into containers. Here is an example problem. Suppose you have circles of radius 2 cm, then fill a plane with these circles using triangular packing. And to solve this problem, you have to divide the area of the circles by the area of the triangle and then multiply by 100%. First, we need to get the area of the circle using the formula pi r squared. And since we have a given radius of 2 cm, we just have to substitute the value. And then put that on your calculator, you'll get 12.57 centimeters squared. And then we just have to multiply it by 3 since we have 3 circles inside the triangle. Then you'll get 37.71 centimeters squared. And that will be the area of the circles. And after getting that, the area of the circles, you have to get the area of the triangle, which we will use the formula 1/2 times base times height. And since our base is already given, we just have to find the height of the triangle. So in finding and solving the height of the triangle, we'll have to use the Pythagorean formula, which is c squared is equal to a squared plus b squared. But since we're looking for the other leg, we'll use the formula b is equals to the square root of c squared minus a squared. And then substitute the values. The c squared will be 4 squared, and the a squared will be 2 squared. And then put that on your calculator. Put the square root of 4 squared minus 2 squared in your calculator. You'll get 3.46 centimeter. And then after getting the height, you can now solve for the area of the triangle. So 1/2 times the base 4 times the height, which is 3.46, you'll get 6.92 centimeters squared. And that will be the area of your triangle. So area of the circles divided by area of the triangle will be 37.71 centimeters squared divided by 6.92 centimeters squared. And then multiply that by 100%, you'll get 5.45%. And that will be your answer. Okay. So our next topic is world population. In world population, we'll be using a formula. A is equals to P E raised to RT. A is the total population after it grows, and P is the initial population or the original or starting population, and E is a constant which has a value of 2.718, and R is your growth rate or your population growth rate, and T is the time. So here we have an example problem. The fictitious town of Greenville is growing at a 3.5% population rate. In the year 2010, it had 8,300 residents. How many people will there be in 22 years? So the first thing we need to do is to identify the values in the problem. So we have an initial population of 8,300 residents, and then a growth rate of 3.5%, which we have to remove the percentage. So what we have to do is to move 2 decimals to the left, and we'll get 0.035 as your growth rate or population growth rate. And then your time is 22 years. Next, just substitute the values. P is 8,300 times E, which is the constant, raised to 0.035 times 22. Then the next thing you have to do is to input that on your calculator like this, and you'll get 17,926. That means there will be 17,926 residents in the town of Greenville in 22 years. Another topic is the Fibonacci sequence. In Fibonacci sequence, you simply have to add the first two numbers starting from 0 and 1. So 0 plus 1 is equals to 1. 1 plus 1 is equals to 2. 1 plus 2 is equals to 3. 2 plus 3 is equals to 5. 3 plus 5 is equals to 8. 5 plus 8 is equals to 13, and so on. So these numbers are sequence 1, 1, 2, 3, 5, 8, 13, and so on is called the Fibonacci sequence. So under the Fibonacci sequence is the golden ratio. And the symbol for the golden ratio is the phi symbol. It is the ratio of two Fibonacci numbers. The formula for the golden ratio is phi is equals to A over B, where A is the length and B is the width. And here I have an example of a golden ratio problem. And it says here that a rectangular flat piece of wood contains Fibonacci numbers being 13 cm long by 8 cm wide. Find the golden ratio value of the piece of wood. So using the formula phi is equals to A over B, substitute A as 13 and B as 8. And to get the answer, just have to divide 13 by 8. So 13 divided by 8 is equals to 1.625, which means the golden ratio of the piece of wood is approximately 1.625.